We're on page 798, and in this video, we're going to talk about what happens to our probability when we are not replacing. So maybe that's one thing to highlight or circle or underline is that in a not replacement situation, things are going to get different, right? 1A, we're reaching into the same drawer as page 797. We're finding 2 red socks, 1 blue sock, or 3 green socks. But once we take that sock out of the drawer, it's going on our footsies, and we're going to draw a second sock to cover the other tootsies. And so therefore, we're not going to have the same probability every single time. Since the action of choosing the first sock is affecting the second choice, once you draw a blue sock, you don't have a blue sock to draw anymore. This is a dependent situation. Yes, the outcomes are affected. The choice, it's not really a choice. It's just the action of drawing a sock out of the drawer, but we'll call it choice for now for short language. The choice of the first sock prevents a repeat. And because a repeat is prevented in the second sock, this is a dependent situation. The next step says use a diagram or organized list to represent the sample space for this situation. So I'm going to use something called subscripts. There's a red sock and it's the first one. There's a red sock and it's the second one. There's just a blue sock, no need to delineate first or second. There's a green sock and it's the first one. There's a green sock and it's the second one. And there's a green sock and it's the third one. Can be a little challenging or annoying to try to sort that whole thing out, but in this situation at least, we're able to outline all of the possible events. Now we're talking about the sample space. So when I'm done with this tree diagram, I should have a snapshot of every possible arrangement if I just follow the branches down through the tree diagram. If I draw the first red sock, calling it R1, then my options remaining are the second red sock, the blue sock, the first green sock, the second green sock, and the third green sock. So 1, 2, 3, 4, 5 total options reveal themselves. R2, blue, G1, G2, G3. That's just one possible scenario of drawing the first red sock and then what's available after it. So for red 2, that would be a different scenario. In fact, why don't you go ahead and skip forward a few seconds, like 20 seconds or so in the video, just to make sure that you're building your answer to 2B the same way that I'm building mine. And we'll compare notes when we're done, all right? So pause, skip forward 20 seconds, see if you did the same thing I did. Ready, go. Okay, maybe you're back, maybe you skip forward and you're getting resynced up to when I finished my tree diagram. But there it is. There's 1, 2, 3, 4, 5, 10, 15, 20, 25, 30 different arrangements or outcomes that are possible. Reminder, using the counting principle, if the first row had 6 outcomes and then each of these branches are all the same, they're all 5 outcomes, then 6 for the first option and 5 for the second option makes 6 times 5. 30 total outcomes. Calculating the probability of a random choice, like the probability of a blue sock and then a red sock. So capital P for probability, getting a blue and then a red. Well, when we look at our options, I might as well try to use the highlight color that matches. Where's my blue? There's my blue highlighter. There we go. Getting a blue sock and then a red sock would be those 2 options, or in other words, 2 out of 30. Calculation here gets a little bit weird, but if we consider this one row at a time, the first probability would be 1 out of 6, and the second probability would be of these options, there are 2 that are red out of 5. So 2/5. That's where the 2 out of 30 comes from. All right. Probability of getting a red sock and then a sock that is not blue. The next one, probability of a red sock and a sock that's not blue. So we can consider this in the stages of you could have drawn that red sock out of the drawer, or you could have drawn that red sock out of the drawer. Notation, probability of red and then not blue. The little C up on the shoulder here, right? That is the complement, and it really represents the word not. So whenever you see a C show up, complement means not. There's another notation, but this book doesn't use it. So C is the notation for you to know for right now. If you take a probability and statistics class in college, or later on they might use another symbol, but it still means the same thing, not that. Which means after you draw that red sock, we just want not blue. So you could get that sock, the other red one, that's not blue, or one of the greens, or the other green, or the other green. So actually 4 out of 5 options available. Same thing, red, not blue, not blue, not blue. So our probability is 2 out of 6 for the first choice. And after you do 2 out of 6 for the first choice, we're going to multiply by 1, 2, 3, 4 out of 5 for the second choice. But if we wanted to like literally count them all out, it'd be this one, 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 and this one. That's 8 total branches that terminate in red, not blue. Red, not blue. 8 of them that do that out of 5, 10, 15, 20, 25, 30 total choices. But that's how you multiply the fractions. Top times top, bottom times bottom. Last one, 2 socks with the first sock being green. So the probability of green and something else, right? So I use question mark. There might be another arrangement for that. Let's bring in orange. Okay, I don't have green. I'd use green if I had green. I don't have a green highlighter. 2 socks with the first sock being green. So that's the first sock. It's green. That's another first sock choice. That's different than the other one. So alternate universe, but still a green sock. Or it could have been that one. That would be 3 out of 6 possibilities. So 3/6 times. Then in the second row, remember, we got to count all of those that are, the first sock being green. First sock is green, first sock is green, first sock is green, first sock is green, first sock is green. It doesn't really influence anything. We have 5 options. And there are 5 total options, but the first sock was green. So first sock, first sock, first sock, first sock. First sock is green. First sock, first sock, first sock, first sock. First sock is green, which means there are 5, 10, 15 out of 30 possible combinations. Of course, that reduces to 1/2. 1/2 is probably the better fraction, but it's not very informative for what's going on in this scenario, that there are 15 choices out of 30 total choices, which is 1/2. But it's better to show this because we know how many outcomes there are. So can you help me out? What's different in the calculation between question 1, part D, and question 2, part D? That would be these, right? Compared to previous page 797. If you haven't done page 797, go back and do it. So just a real quick glance here. Really, it's the second fraction if you didn't notice. How is the second fraction from question 1 similar to the second fraction from question 2? Do you spot it? That's not the second fraction. This is the second fraction. Really, it boils down to the number of outcomes that are available. So I'm going to say it and not write it, and write it after the video is over, and maybe you'll see it in page 799 video as we kind of flip back and forth. But the point is, the difference between the calculations is what our denominators are, the bottom of the fractions. In the first fraction, for both problems, there were 6 total outcomes. But once you have do not replace, you drop the number of options by 1 or more, but usually by 1, as that option is no longer available to you in the second of the options. So we went from 6 to 5. If we kept drawing socks without replacement, we'd be down to 4. What's different about the calculations in question 1 part D and question 2 part D? The options available for the second event. In question 2, there are less options because we are not replacing socks. I'm going to write that. You're going to write that. Thanks for watching this video. Page 799 is next. In the next episode, we're going to continue talking about dependent events. Activity 3 is still in motion. Thank you for commenting, and subscribing. See you in the next video. Bye.